Welcome students. Today is the 35th class on digital land surveying and mapping. In today's class I will discuss the salient steps that is to be taken for carrying out the digital surveying and mapping, that means leading to preparation of a topographic map. So the objective of surveying is to prepare a topographic map of an area, and the objective of this course is that how to prepare the topographic map using digital data collection and digital way of mapping. So actually for development of any topographic map, the most important thing is to know what is the objective for which we will like to have our topographic map. Like I may make use of topographic map for constructing a building. In that case I will be in need to prepare the map into with certain specification, or we will be in need to collect the data having certain quality. Or if I want to go for making use of topographic map for town planning, in that case I will be in need of topographic map having of defined specification, as a result of which I will be in need to make use of different type of instrument, defined quality of data. Like that type of map we will prepare, the type of data we will collect, the quality of the data we will be collecting, and many other specifications, as well as all activities will depend on first what is the objective for which we will be going for making use of the topographic map. So the use or utility of the topographic map will guide for our further action, activities, methods, instruments, and every other details about our digital surveying and mapping. Now once the objective has been decided, like maybe we will be using the topographic map for constructing a building, or maybe town planning, or maybe any other engineering project which has to be defined, then we have to decide what type of quality of the map we will be in need to go for that type of activities. Now depending upon that, then we have to see what is the specification of the surveying, that means what should be the quality of data that we will like to have to meet the specification to meet the objective of the topographic map. Now if we want to go for first order surveying or second order surveying, depending upon that, already I had discussed in some other class about the type of order, and then in that guides us the quality of the measurements. So based on that actually we have to decide. So we need to go for specification of the surveying, that means what should be the order of the surveying work, what should be the and on the basis of that we will have to decide about the type of instruments to be used, because each instrument does not provide us the equally good quality of data, and quality of data will also depend upon the type of instrument as well as cost of the instrument. So if I need of very high quality data, we need to go for some instruments which will be very costly, so our project cost will be very high. So and then also methodology will depend upon what type of instrument we will use or what quality of data we will like to have. So then another specification which is important, that is a mapping specification. That means what will be the quality of mapping, that means, and specifically mapping quality will depend on two ways. One for planimetric scale, that means if we want to have a very precise map, we will be need to have large scale map, and if we go for large scale map, then we will be need to have a very precise quality data. So if we go for precise quality of data, that means we will be need to go for a lot of measurement, as well as measurement should be taken by very good instruments. So project cost will be high, time taking will be high. Now another point which is important for mapping specification is the contour interval, that means vertical scale. So in case of building project, we will be in need of having contours at very close interval, that means difference in height between two consecutive contours should be less, and for having that type of contouring, we will be in need to have a lot many spot heights and height data of the study area, and as soon as the number of points whose height has to be taken more number of points will be involved in mapping purpose. So we will be need to go for a large number of observation, the time of surveying will be more, and the cost will be more. So specification should be decided in the beginning itself, and that specification will depend on the objective of the surveying, objective of the topographic map. Once the specification has been decided about the surveying as well as mapping, then we should go for actual land surveying. Now in case of digital land surveying and mapping, establishment of control point may be a single control point, or it may be number of control points, or it may be a network of control points. So what will be the number of control points, how it will be established, and all these things has to be first taken into consideration. And the establishment of control points consist of 4 broad operations. First we have to go for planning, and then we should go for actual field survey, then we should go for processing, and then transfer. Now in case of digital land surveying and mapping, actually we will like to make use of GPS for establishment of control point. Now depending upon the specification of the control point, that means specification of surveying, what type of survey we want to do, that means what is the order of the survey, we have to choose the type of instrument, GPS receiver, and like if we want to go for the highest order control point, then we should go for very highly accurate GPS receiver like frequency receiver, dual frequency or triple frequency. Now all these come under the word planning. So to establish control point, first we should plan. So planning consists of first to visit around the area called reconnaissance survey, and reconnaissance can be done in 2 steps. First we can do the reconnaissance work in the office by making use of the existing maps and Google map, and to come across about the area, to have an idea about the area, and then in the existing map, which is also called base map, we can locate the possible station points. Now station points which can be used as control point will depend upon our specification. So if we want to go for very high order specification, then we should be very precise about our instrument location, and we should accordingly plan. So after reconnaissance survey, then we should think of what are the instruments to be used. Again, the type of instrument to be used depends upon the specification. If we want to go for very high order control point, we need to use very sophisticated GPS receiver which are very costly, and generally the dual frequency or triple frequency receivers are very precise, or it provides very good location and highest order GPS control points. So, and also we have to decide about the methods, but establishment of control point we do go for static method invariably. So, about the method it is fixed, but about depending upon the specification of the control point, we have to decide about the duration of observation. That means if the higher the order, longer will be the duration for observation, and also we need to decide about the epoch of observation. For establishment of control point, generally we take epoch of high duration like 15 seconds or 30 seconds. So, like that we have to plan the different activities. Then one more thing is important is that planning is that network design. So, how the network design means how these station points will be considered and how the observations has to be done in different control points. Of course, this thing I will discuss yet more when I will take up the lesson on establishment of control point. Now, once planning stage is over, means we decided where is the what is the location of the station points where we will go for establishment of control point, and how this observation will be taken care of, what will be the duration, when it will be taken, all those important, what are the instruments to be used, and it is the static method of surveying which we will do. So, with this background we should go to the field using our instrument, with our instruments, personnels and enough resources. Now, once we go to the field, then we should go for actual surveying. Now, surveying using GPS receiver consists of first locating the station points which we have already decided in the field, and that has to be marked properly, and on that station point we should set up our instrument properly. Now, setting up of GPS receiver means first to set up the tripod stand as I had shown you in some other classes, and then on that tripod stand should be properly leveled as well as properly centered over the station point. Now, once this tripod stand has been set up, then we will fix up the antenna. Generally, antenna is the part of the receiver which is placed over the station points, and then antenna should be properly connected to the receiver as well as to the controller, and there should be adequate power supply. Now, that is a very important point in case of establishment of control point or in case of GPS surveying, that the supply of power should be adequate during which all throughout the observation. So, we have to pre-plan what will be the duration of observation, and accordingly we have to make available the power. So, and then after setting up the instrument we had to go for giving the different data to the receiver, that is called initialization, like cutoff angle, then epoch of observation, then our in which coordinate system we will be taking the data, etc. So, there are so many other things to be given. Once this has been set up, then as per our pre-plan we have to take the data, go on observing the data. Now, while doing the data observation we should go for intermittent quality checking. So, once the data has been collected, then we should also process the data. After during processing, actually as we already know that GPS data may not have the proper quality, then we have to improve the quality by doing some processing techniques, or when the quality is sufficiently good, then we should go for further processing. Now, processing involves pre-processing, where we convert the good quality data to double referencing, and then double referenced observables has to be processed, further processed to find out the location of the control point. Now once the data has been processed, then and we got the point, then we should transfer the data. The further detail about the control point establishment will be discussed in our next class. So once the control point has been established and we have located the point and we had collected the data and we have processed the data and we got the location of the control point, then that location of the control point has to be transferred to the total station, because we will make use of total station to collect the detailed information about the topography of the area, that is called detailed survey. Now for detailed survey, that means to collect the detailed information about the topography, that means what are the objects present, what are the important objects which are relevant to our objective of work is there, what are the objects we have to omit, which of the object we have to take into consideration, then how many objects we have to take into consideration, what are the defined points we have to consider, what are the how many spot levels we have to take. So there are so many other things will be there involved there, which as per the specification, surveying specification, we have to decide, and that has to be planned. So during planning we have to decide about the field activities to be carried out, as well as about the instrument to be used, whether these instruments are properly working or not has to be checked, and then if there is a requirement, then permanent adjustment has to be checked through laboratory. So all this thing has to be done during planning. Now once planning has been done, then we have to take our instrument to the field for actual surveying work, that is called field survey. Now in case of the total station, the field surveying is done by two methods basically. One is for backside method, in which we will be in need to have at least 2 points whose coordinates are known. So that thing we will do by making use of the GPS survey, which has already been done. So from GPS survey establishment of control point, at least 2 control points we will like to provide for carrying out our field survey work using total station, and those 2 points will be used by method of backsighting to establish the location of the total station, and subsequently those different points or objects has to be collected or noted down. The location of the objects has to be noted down along with their defined features. That means if there is a tree, we not only will locate the coordinate of the tree, but also we will note down along with that it is a tree, or corner of the building, or lamp post, or corner of the road. All these things we have to note down during field survey. Now another way how we do go for, sometimes for some point, some area, suppose this is the area for which we will like to go for surveying, and we have a control point somewhere here, another control point somewhere here, but we will be in need to do the survey all throughout. So maybe by setting up our instrument, first we will set up our instrument on one of the control points, and we will give the coordinate to the total station, TS as station, known point, known location, and we will take the backside to this, and that is also known location. So from this to known location, these both are GPS station or points, GPS control points you can say. So this is the thing we will start with. that is called back sighting. This is the backside station, so back sighting. So we will set up the total station on a point whose location is known. This we will find out by making use of GPS in digital land surveying mapping. Then we will take a backside to a station whose coordinate is known. That point is also our location, whose location has been found out by GPS surveying. Now in doing that, the azimuth of the place has also been, the azimuth of this line has also been, can be determined, because we will like to give the coordinate in northeastern height coordinate system, and then any other point, suppose there are so many other points, objects are there which we will be able to identify, like trees, telephone line, road corners, like these points. We will note down the using the total station, corners, salient points, and then there may be tree, telephone line. There may be some, this area may not be visible from this side, so I may, next we will set up our instrument somewhere here. Now because there is no control point here, then in the location of this will be established by already known. Suppose this is known, this is known, this location is known, and this location is known. So from the already known location, by method of resection, by method of resection, we will find out first the location of the total station. Then once the location of this station is known, then we can find out the location of other things. So this thing already we will discuss in another class afterwards. So in that way we will like to collect the location of different objects as well as their feature. So once this is over, that means our land surveying operation has been done. Then we will go for our data preparation. That means now actually GPS provides us data in WGS 84 coordinate system, and there may be, it may be of latitude, geodetic or Cartesian coordinate. So but generally we prepare our map using the local coordinate system, as I told you, northeast height. So the WGSS coordinate has to be converted to northeast and height. Now for that, first we need to transform the geodetic height to orthometric height, already we have discussed, and the lat long or XY or the XYZ can be converted to northeast. So this is the way, first we will transform, then once the coordinate has been transformed, means once the location of GPS is transformed to this, then the location of our total station can be converted, that is called reduction. So reduction will be done for all the points whose location has been found out by using total station, that has to be converted to any age. So that is called reduction. So transformation and reduction has to be done before we import the data to the mapping software. Now to the mapping, as I have already discussed, there are different types of mapping software, and each software has its own advantages and disadvantages. So depending upon our specification, as I told you, specification of mapping is also important. So as per the need of our specification of map, we have to decide what will be the, which software we will be using, and once we decide about the type of software where the mapping will be done, then we have to convert all our data, reduced data, to the format that the particular software supports. Now once the mapping software imports the data, then those data will be kept in a file, and then now our mapping software may independently do planimetric mapping and contouring. Some mapping software they does all these things together. So depending upon what type of modules are available, let us say first planimetric mapping. So all the points will be taken care of, the planimetric position as well as feature. So in planimetric mapping, the software will take care of the planimetric position like northeast, and the feature like road corner or tree or building corner, etc., and accordingly it will be depicted in the map. Now that those points has to be meticulously represented along with symbols. So we have to take care in making use of appropriate symbol that has to be used for particular to do note down different particular object. Once the planimetric mapping of the area is satisfactorily done, that means we have to compare our map with the actual area, and we have to see whether all the objects or all the features which we wanted to note down in the map is available or not. So if it is fine, if it is not, then we have to take care to get all those things to be done and properly noted down using the appropriate symbol. So after planimetric map has been done, then we can go for contouring. So for contouring we will be need to have all the three coordinates like northeast and height. Northeast will provide the planimetric position and height will provide the height of the point, and then then each and every software has their own techniques for interpolation of height between different points. So we can make use of the interpolation technique which we find to be suitable for our work, and we can do the contouring. Sometimes we can test whether our contouring really represents the field which really we want to represent, and sometimes we maybe need to change the interpolation technique to get the appropriate contours. So once the contouring and planimetric mapping has been done and put together, then we should go for different cartographic elements to be shown, like the direction of the north, that is scale of map, then symbols, legends, and many other things as we have already discussed. And once all this has been done, proper color has to be used. So when all this has been used and we are satisfied with the representation, then we can say that our final map has been prepared. So before really we want to say that our map is representing appropriately to the field, we have to compare our map with the actual field and to see whether really all the objects and features which we wanted to represent is available here or not, and the contours which we have represented in our map really represents the type of topography that we wanted to represent in the map or not. So when satisfied, then only we will say yes, our topographic map has been done. So these are in short the different steps which one has to make use or one has to adopt in sequence to develop a topographic map by digital land surveying and mapping. Thank you.